So, ladies and gentlemen, we'll be starting in less than 1 minute. On s'est vu, c'est avec Impalabridge tu travailles avec Impalabridge aussi ou pas?
Non, moi je suis consultant SAP.
Ah, ok.
Mais là, j'ai vu ton message sur LinkedIn.
Ok.
Je me suis dit que j'allais passer parce que j'ai cours d'informatique de gestion, un bachelier en informatique, et je dois faire un TFE là-dessus.
Right, ladies and gentlemen, can you please go back to your seat now? Okay. So let's start again. Shall we start again? Is that okay?
It's because I work so I can be there.
Mag ik nog iets hebben voor te drinken? Ja? Est-ce que je peux avoir un Simone a soif, le fraise, s'il vous plaît, cette fois-ci?
So, this next step now is going to be going into more details. Serge will give you an example of the work he has done this summer, being inspired by Jenny, seeing what she has done, trying to do it his way, and being confronted with a lot of issues that he wants to share with you so that you have an idea of how complex it could be. And he will also give you some hints on where he found interesting information so that you could also work on that. Yeah. After Serge's presentation, we will go into question and answer mode for about 10 minutes so that I have tons of questions for Jenny, so ask the necessary questions. If you don't want to be part of that question and answer, and you already have your group, we can already split into your groups. There will be one group who is going to think on where can I find some additional data, and there will be another group who will very be eager to upload the data from Jenny and start working on it. Yeah. So basically, after the presentation from Serge and after the Q&A, you're free. And the only thing that we want to do is to have you out of here by 9:29, and then everybody will be safe. So have a good evening and get inspired by Serge's presentation.
Okay. Can you hear me okay? Yeah, that seems to work very well. So I'm going to talk about my experiences in trying to make my hands dirty in an exercise, HIV drug resistance in Tanzania. Next slide, but it's me that has to do that. It's okay. You listened very carefully to Jenny's presentation, and Jenny's presentation was about a data set that basically gives a resistance number per country. 7% resistance in Tanzania, 6% resistance in Kenya. And the feedback that we always get with, and the data set that Jenny is putting into the hackathon is a real data set. We are using that today as we speak for a project, but we cannot unfortunately disclose the outcomes that we have so far. On the other hand, we've taken a few things out of the data set to allow your full creativity so that you are not biased by any twitch and glitch that we have put in there. So just to get new perspectives. Otherwise, if the whole world is painted red, you're gonna likely think in red. And we took the color out just that you come up with a different color and a nicer color, or maybe many colors. Now, with the work that Jenny has been doing so far, as I said, it's 7% resistance for Tanzania, 5 for Kenya, what have you. The countries that we, or the people that we present this to, always say, yeah, it's nice, great work, fine, but what is in it for a country? Why would Kenya be interested to know that they have 7% resistance and Sierra Leone 5 or 3? A value proposition to a country is what is happening inside my country. If you're the Minister of Health or the Chief Medical Officer of Sierra Leone, you're probably more interested to know what is happening inside my country. Where do I need to do something? Do I need to do it in the northeast, in the southwest? Do I need to do it in this province or in that province? And so here, the next step in this whole endeavor, what has been done at a global scale, can we now try to do that at a regional scale, inside a country? Can we take some of these ideas and port them to within a country? And then, so that's why this exercise started from the perspective, can we do this vertically, instead of looking across all the countries, really zooming in and focusing on one country and go very deep into that country. Well, so continuously looking for data on one particular country. Now, why did I choose Tanzania? Basically because at one point I stumbled across an article that gave the viral load suppression, so the amount of viral load has gone down at a regional level in Tanzania. And so I was like, oh, if they kind of put this out there, maybe there is more to discover. And so I went on and kept on searching and searching, and I'm going to give you a perspective of that today, because that is going to basically show you how challenging this exercise is. So with that, basically today there is some material available, and it's also been shared already in the drive where Jenny has put her material. So hopefully that can help as an additional data set for another team or another perspective. And so if we can use that, maybe that's a starting point to go to Tanzania and say, oh, see what we've done with publicly available data. If we now can exchange data, you bring other data, we can perhaps do more. So it's like a value proposition. It's a quote-unquote exchange mechanism of, this is what we can do, give us more data, give us better data, and we'll do more for you. Quite to my surprise, and I started around the beginning of June, the more I dived into this, the more data I discovered publicly available. So, and I just spoke with Saira, and I said it was actually very frustrating because sometimes I was very happy. Jenny knows that, Annalise knows that. Oh, I found this data, and then the 2 days later, yeah, but it's not really that, and I need to find more. But I guess for those of you who are in data science, you already know that. For those you are not in data science, and I saw a few hands being raised, stepping into the boot camp, well, I'm glad to say this is what you're going to experience in your work with data science. But the reward is big. If you then have a model and have some prediction, it's a fantastic feeling. I'm not going to go into detail, but just to give you a flavor, and this presentation is shared, so for those of you who want to continue on this Tanzania exercise for whatever reason, these are already great starting point in data sources that are out there. So you don't have to find these, they are already there. And it's even 2 slides. Voila. So as you can see, there is the National AIDS Control Program, Tanzania Commission for AIDS, National Bureau of Statistics, the Tanzania Budget Explorer. I was really surprised to see that they have these beautiful dashboards where even our government should be very jealous about. The beautiful dashboard showing how much money they contribute to agriculture, to education, to healthcare across the years by region. So from the perspective, we're dealing with low and middle income countries, we were really surprised from, wow, this is not what you would typically see from a low and middle income country. This is actually great. So there's quite some information out there. That's good news to start with. If you want to do data science, you need some data. Along the way, quite a few tools were needed, and I guess you guys, boys and girls, are much better at this and finding all these tools. But here, just to give you a flavor of the tools that were applied, R as the statistical programming environment to code and collect and integrate data and what have you. Abby Fine Reader, that is not an open source thing. We spent a little bit of money, 199 euros, to get a fantastic software that was capable of just transforming PDF files into OCR, and you select a table and you click Excel and boom, the table is in Excel. That's great. So, but that is needed. If you want to extract data from reports, you will have to find a way of getting the table out of a PDF. If you want to show nice geographical graphs and you want to show the regions of Tanzania, you need to know where they are. And there's a whole branch of technology out there called GIS, Geographical Information Systems, and there are shape files basically drawing every bit and piece of Tanzania, United States, Belgium, whatever, at various administrative levels, at the country level, at the province level, at the district level, at the ward level, at the what have you level. But you need to be able to visualize it. So here, this one, QGIS, was a open source software that allows you to manipulate all these files and transform them in polygons, which you are then able to draw somewhere else and this and that. But it was quite a challenge to do all of that. Tableau is a visualization software, is one of the better known visualization softwares. It's not license free. I know, working for a company, it's easy for us to say we have that available, these licenses, but okay, they do not come for free. But that was one tool that I used up until the point that Tableau was not really able to visualize all the data, especially the polygons on all the regions, and I reverted back to Shiny. I would say good old Shiny, but it's not good old Shiny, it's basically brand new Shiny, and that seems to work pretty well. So it was quite an endeavor to discover a shapefile and how do I visualize this and that and install this software and get it to work and then upload the data and manipulate it and change it to get to a reasonable outcome. That was a challenge as well. The data model, and that's what you're going to find in the uploaded set. The data model basically is centered around, okay, we have a time indication, the year, that's already quite enough. We don't need months and quarters, but the geographical unit, that can be the name of a region or the name of a country. In the case of Tanzania, it's Arusha, for example. It's one of the better known regions and cities. The geographical level, so Arusha is a region, Tanzania is a country. That is what you're going to find in the data. The gender, you will find data out there on HIV, on population, and what have you, that will say this is the amount of, or the population of females, this is the population of males, this is the HIV prevalence in females and males, so, or both. If it's for all genders, then it's actually a number that combines the two. Age, typically, we talk about age categories 0 to 14 years, that's young people, young. Then adults, 15 to 49, yes, and then seniors, 50 plus. There's not that many in the room, but still, it's actually not feeling right if you're 50 plus to be called a senior. So for today, we're still in the adult category. Anyway, it's quite important when you discover a data set, and the data scientists in the room, they know, and the new ones, they will learn it by hitting with the head against the wall. If you find a data set and it says it's only for females and it's 15 to 49, well, you cannot add that up with something that is for all ages and for both genders. And that's actually what my next slide is. Well, no, not yet. The gender reference is there for both, if it's for both genders, male if it's for male and female. The ages are the age categories, so typically 0 to 14, 15 to 49, 50 plus. And the data type reference. When scientists look at data, they want to know, where does that data come from? Have you found it in a report? Have you calculated it? Was it a data scientist here? Did you apply some fancy algorithm to impute the missing data? If they see a figure, 7.5, they want to know, have you found that in some documentation and some report, or did you calculate it yourself? And that's basically in the set of files that you may use. That is an indication of, did I found it somewhere? Did I calculate it myself? Or was it an estimate? Or was it a straightforward addition, A plus B is C? That's very simple. So that is about the data set that is in there and how it is structured. Some of you may recognize star schema and data warehousing perspective with your fact table in the middle and some dimensions floating around it. Anyway. I already alluded a little bit to it. The math has to add up. So when I started this, I then discovered somewhere a data set that talked about the number of people living with HIV, and I had then calculated it myself based on a couple of other variables, and guess what? That was what the literature said, and that was my calculation. And there another level of frustration that the math didn't add up. And that's how I got to the point where, fantastic. You can basically not add up everything as you discover it. You have to be very, very precise in how you do things. So if you have the number of HIV cases at the ton, or the prevalence, for example. The prevalence is the number of, the percentage of people relative to the population that live with HIV. If you have that at the Tanzanian level, and for both genders, and for the ages 15 to 49, then you basically have to multiply that with Tanzanian population for both levels for 15 to 49. So how do I get now the age cohort 15 to 49? Well, coming back to all these tools and all this frustration, I found somewhere a website that shows the age pyramid for Tanzania for 25 years and basically says this is the percentage 10 to 14 years females, and this is the same percentage. And then I use this fantastic OCR tool, ABI Find Reader, to get all these little numbers out of these graphs, transform that into a data set, which allows me now to basically calculate the percentage of population that goes from 15 to 49, which goes into this formula, which goes into this formula, and then gives me a result that is now acceptable. The trick was that population data in this kind of formula needs to be relatively okay, and even that was a challenge in itself. Countries do not do a census every year. So in the case of Tanzania, there was a census in 78, 88, 2002, and 2012. And with these four numbers, you have to basically do it. All the rest is missing data. And so that was one of the big frustrations. Damn, sorry for my French, I don't find any good population data until one day on a Sunday morning, very early Sunday morning with a cup of coffee, browsing and browsing again, I stumbled across a data set that has population projections for 25 years for every region of Tanzania. Whoa. And that was then what got the ball rolling again. So this is what you're gonna encounter. And in doing so, that allowed me to calculate the percentage of population in a particular region with 15 to 49, and then do this, and then do that. Basically, that's what got the ball rolling, but it took a while before you stumble on such a report. Looking into Tanzania population by region, that at a particular time basically stopped. I didn't see anything else until I tried another search term which opened up things. And so that's why you all together, you might look into, you might say region population, and you might say population region and get a different result. And that's what's so helpful in having many hands instead of just two hands. So it starts to show some output. This is the shiny thing where you see the regions of Tanzania where you can apply some data range, where you can color the background according to a particular variable, in this case population, where the size of the dot here, the shape is in this case the prevalence for that region, and where the color of the little dot is the case. So it starts to make some sense, the whole data set. And so, is this one? Yeah. So where is this data now? In the Google Drive that was spoken about earlier, you will basically find all the input data, all the publications, all the input, the raw data, the worked upon data, the final data, the scripts that allowed to produce all of this. There is a file in there called dataset overview version 1, which basically describes the whole structure of the data set and the variables that go in there and the folder structure and where you can find what and so on. And there's also a document called the cookbook, which is basically the documentation of how I went from A to B and what kind of assumptions I took to go from A to B, which is also very important. So that being said, lessons learned so far, it's quite remarkable how much data I found, which is a good thing. I'm going to put the bad thing out as well. With good news, there is always some bad news. And that is, I have not discovered any resistance data so far, which is, of course, for the hackathon that we want to do, model the hotspots of drug resistance. That's a bit of a bad thing. Now, that being said, let's not nail ourselves down on resistance per se. If we can do something about predicting virological load or virologic suppression, that's already a great starting point. If we can show some value there and go with that to a country and say, well, if you now release your HIV resistance data to us, that's what we can bring as value to you. So that's what I'm saying in the second bullet there. We have no resistance data for Tanzania so far. And so we might need to revert or try to do something with virologic failure. Some reports are still lagging in time. Countries take some time to produce a report. Just maybe a week ago, the report for 2014 was produced. So it's a bit of pity, whether it's on purpose, that they do not want to put this in the open in the public, or whether it's really on purpose that it takes that amount of time to produce a report, I don't know, but you will find lagging data in time. Jenny also spoke about it. You really need to look carefully into the definitions of the data that you find. One of my challenges before, for example, was I had discovered a data set and I had seen HIV cases. Wow, great. I jumped upon it, running blind, working on that data, only then to discover that the math didn't add up. And then I had to go back to see what is happening here. And it was actually reported cases. Now, why is that different? Reported cases is the clinic that reports, oh, I have 5 people here with HIV. That doesn't say that there are 5 people living with HIV. That says I have seen 5 people in my clinic. If in that region that that clinic serves, there's 150 people living with HIV, you don't catch that by 5 people showing at the clinic. So if you then looked into the small print, it said, yeah, it's only reported cases, which is not representative for actually the number of people that live with, but we estimate that only 20% is being reported. So you had to multiply by 5. If you then did that, the math didn't add up, and so I used another trick, which is explained in the cookbook. That said, population data has proven to be like the thing that you need for as a solid basis, because many things are a percentage relative to population, and if you want to calculate and calculate back, your denominator needs to be a solid one. In some cases, published data are estimates. Countries do not know what their HIV prevalence is. How this is typically done is that women that are becoming pregnant, they go to see the clinic, and that's where they are being tested. And so basically the prevalence of a population is an estimate that is based upon the number of women that come to a clinic that have been tested positive for HIV. So even what you read in the document is not the real number. It can be a projection, it can be an estimate. In this case, it's a well-known and established estimate. So nobody will challenge you on that one. But just to give you a feel of what you read is not always the real number. It can be an estimate. And then in your exercise, you have to take a lot of assumptions. If you don't find the age pyramid per region of Tanzania or any other country for that matter, and you need it, you will have to make an assumption. In my case, for example, I said, okay, I distribute age pyramid similar across all regions. Good or bad, I don't know. And so a few other. But the thing is, document your estimates, your assumptions, I'm sorry. Document them so that people who read your work, or if you get back to your work after 2 weeks of holiday, that you actually know what were my starting points, what were my assumptions, why this. And then people might challenge you, but your assumption might also be reasonable, and people will say, yeah, okay, I think this is fair, continue. But basically, the message is document your assumptions as you move forward, because it's growing and growing and growing in exercise, and so you will forget by the time you're at your end point, you will forget what your assumptions were at the starting point. So where can you help? Because that's what the hackathon is all about. Continuing the exercise for Tanzania, there's still a lot of data out there that I haven't captured yet. Just recently, a week ago or so, I stumbled across a new website, and they seem to have all sorts of data on what they call tracker medicines. Tracker medicines is a set of 30 medications, that they trace the availability of that medication in the pharmacies by region. Now, let's bring that back to my earlier presentation where I said drug stock outages have an influence on the emergence of drug resistance. Now, in those 30 medications, there's actually 3 or 4 HIV-related medications. So all of a sudden here you stumble across a website, a dashboard, it's reports in PDF that show you the availability of HIV medication in pharmacies across Tanzania. Whoa. So, that said, there's still a lot of data out there that has not been captured, that is not present in the data set, so therefore an appeal for your help to help capturing and collecting that data into the data set. In this case, transform the PDF into a data set and then take the appropriate columns out and put them in one single set. That said, from time to time you need to validate your work. And so, for example, you put together an awful lot of data based on this and this and that, and then 2 weeks later you read a new report about the HIV prevalence in the regions. Well, do your graphs actually match up with that newly published graph? Does it make sense? It doesn't have to be precise at the number behind the comma, but does it make sense? So validating what is in the data set, is that actually being observed in the reports? That's an important case if you want to work on the data. Then, of course, what it is all about. Some time ago, it was said in Time, I believe, that data scientist was the sexiest job of the 21st century. So now we get closer and closer to that sexiest part of the job, using the data, trying to make sense out of it, trying to visualize it as a first model, basically, or trying to apply a model. So use that data. Because there's no resistance data, there might be some unsupervised techniques that might apply here. And with virologic failure, for example, there might be an opportunity to do some supervised techniques where you model first known input to known output to validate your data set and then to apply it to unknown output. Just earlier in the week, I got some feedback from people in Tanzania stating, well, here's a list of publications, whatever you PubMed, Lancet, publications on HIV drug resistance. That is not a data set as such. Here you have 2%, there you have 3%, there you have 7%. But maybe there are some clues in there that we can translate into some data set. Don't know. That said, I think to do that, you need to be a subject matter expert. So maybe there's a doctor in the room, an MD, who can help doing that and looking into those publications and make sense out of the data. So that is not a typical data scientist work, but maybe for some specialized people. And then, last but not least, I took Tanzania on the basis of that article that was maybe good, that was maybe not so good, that was maybe a good starting point to go through all this trouble, getting us to this point. But in essence, the technique, the methodology might apply for other countries as well. Kenya, Uganda. And as another person spoke, I had to kind of say, I said to myself, well, first have a look before you tell that to the audience here. And Kenya has a virologic failure dashboard that starts in 2012. That's 6 years of data, by month, by region. So maybe I did take the wrong country. Anyway, we can use your hands to start the work on a different country and try the same thing with better data, with more data. So here are just a few perspectives of where you can help build upon this Tanzanian data set that basically served as an example for the rest of the work on or the rest of the opportunities that might come. And so that was my story with a few challenges. Could not go through all of them, but rest assured, it's heavy duty work in the sense that the math needs to add up. You need to scrape the data and so. But I think it's doable in a way. Maybe not for resistance as such, but with what I have seen for Kenya on virologic failure, that might be a great opportunity. And also know that we as a company, we continue to reach out to people to participate in this Data for Good event and submit a data set that you can unleash your talent to. Voilà. That's it, Philippe.
Excellent, Serge. Thank you very much. So we all want to ask some questions here. We'll limit that to 5 questions in public, and then afterwards you can, if you still have a question, go to each person individually and ask the question there. So who has a question for either for Annelies or for Jenny or for Serge? Hold on, I'm
the
over.
mic.
Hello, Serge. My question is, where do you find sufficient data for Tanzania?
Where did I find it?
Yes,
Via Google.
via Google. And
Googling
it's a second question.
HIV resistance Tanzania, and then you start working, and today you find a few things, and tomorrow if you find a few more. That was the whole thing. Jenny had looked like data sets that gave a number per country.
Okay.
And I took that approach to a regional level and really focused on just one country. And Tanzania is an example, but it might have been Uganda, Kenya, or another country. Does that help answering your question?
I got the second question. Do you had the data from the literature?
Do I have the data from?
You compared your curve to the one of literature.
Yeah.
Do you have this data?
The data is available in the
Yes,
data
yes.
set now.
Is there a difference? In fact, you got the same data or the same model as the data of the literature you get. And so there's, I don't know.
There is no model yet. This was the so what was shown there was the number of people living with HIV calculated from the prevalence. Remember, prevalence times population gives number of people living. And so I found number of people living, and I found prevalence, and I multiplied by population to calculate the number of people living and see if it matches what I found in literature. Does that? Well, let's discuss later.
Hello, have you
Hey.
tried a neural network embedding on some literature data in order to find exactly what are the features linked to drug resistance, to HIV resistance?
Have I tried that?
Yes. If
No.
Okay.
If you want to try. Yes?
I was just curious if you already have those correlations.
No.
Just thinking about countries that you might be able to find good public data for, or you might be able to reach out to them and actually make a contact where you can get data, is South Africa. I mean, South Africa has been collecting data using formal systems the longest, and they have some of the top people in the world in the area of HIV working down there. So it would seem to be, from a country side, perhaps the best place to start digging for more data.
That's a fair point. I didn't mention South Africa, sorry for that. Botswana, have I been told, is also a very interesting country. I'm sorry. Botswana, for being one of the countries that actually do the treatment and the services on HIV care and treatment, do it very, very well. So that's is a country where there is quite a prevalence, but where they have made a lot of progress over the years. So that would also be a good case. But these ones definitely, Kenya, Uganda, thank you for bringing it up. South Africa, Botswana, these are the, if we would need to pick 4, these are the 4. Yeah.
Hi.
Wait.
I have just this small question.
Can you speak up, please?
Yeah. While you were talking about the amount of data you were capturing, like going through days and you were capturing some data from a particular website, so how you were actually relying on that particular website, to validate that data from a particular website, how you were actually, okay, this particular website is really reliable or not?
Fair
Source,
point.
or is it really, okay, I grabbed this particular data, yeah.
It's a fair point. You don't know. So if you find a data set on WHO or UNH, or you have to rely that their data is okay. There's one aspect maybe that we didn't put that much forward in our presentations, and that is that we want to do this project and exercise without putting any additional burden on a country. And that is, we could do or work with a country to do, say, a national HIV drug resistance surveillance program. Going in there, testing people, interviewing people, etc., etc. But that, for a country that is already poor, where resources are limited, it's an additional burden. So the whole concept and notion is basically do as much as you can on the best available data without any additional burden. So that is basically the uniqueness of the approach, and try to rely on data that is collected on a day-to-day basis without setting up a big program to collect additional data to do this. That's what it is about.
One question, when we started this project that I had in my head, and it has been rephrased today as well, is why don't you just pick up your phone and call a local university and ask them to get all the data?
Yeah. We've done that without success, in the sense that, yeah, you might realize, we realize now by now that data is very valuable, and universities is an academic institution. What do they live by and from is publications, research on data. So it's very difficult for them to say, well, here's all the data we have collected in a study, and off you go, and do something with it. So with this and with the data sources that you saw in the beginning, I contacted a university. I contacted 2 professors, okay, via my colleagues and so forth, in Tanzania. We got to we had a meeting and this and that, and now basically it stops in giving access to the data. That is our challenge. The moment we can show value, I'm sure it's gonna open up, because then people will start to realize, this is what we can do with our data. This is how this data basically that we now collect routinely is turning into action, into value for this particular program. But it's very hard. It's like selling a vacuum cleaner. Somebody knocks at your door and says, you know what, give me your money, I'm gonna make you a good vacuum cleaner. Will you buy it? Maybe not. Maybe we will, maybe not. But that's the point. If you can show, I have something here and it works already nicely, now we have something to work upon, and that's basically the challenge. Sorry, Philip, I didn't meant to, when I came here today, I really didn't meant to compare data science with selling vacuum cleaners.
Well, I think we better wrap up here if you still want to have 3/4 of an hour for you to mingle and to start working on things. So this last 3/4 of an hour will not be organized. Most of the time it's not organized when I'm involved. So you just, try to find each other, try to find a space to work on. Maybe do some upload of the data set that Jenny has. Try to find the data set of Serge. Take a look at the Facebook page that we have opened for this event, because there are a lot of videos that we have already recorded on the topic. If you want to understand what is HIV drug resistance precisely, we have had some experts talking about it. And start using the forum. Ask questions. You will get answers from your peers here, and you will get answers from us. Let's start working now. Let's get the thing in motion. We've been pulling it for 3 months. Now it's up to you to jump on the train and start working on it. We will continue pushing and pulling as much as we can. But now it's your turn to get involved with the process in a more active and then Annelies, yeah.
I wanted to quickly mention something. The one thing that I hope you guys have realized already, for those of you who've already been to a different hackathon, you might have been used to getting a very specific set of data that is already clean, that is already integrated, and they ask you for a very specific question. Okay, we want to have the model with the highest accuracy that can predict the best this and this situation. This is not the kind of hackathon that we are having. What we are really asking is for a community effort to come together from the start of the data science aspect all the way through to the model. So we do want to help finding the data. As you can see, Serge and Jenny have already done a lot of work in trying to find data. Well, we want your help to find even more data. And then we want help in integrating that data and figuring out, okay, what could be data sources that are good to put together. So we want to do that as well. And then, of course, comes the modeling. But imagine we don't have, because as we said, the biggest challenge so far is finding that drug resistance data. What if, worst case scenario, we don't find it, or we only have the data that Jenny provided on drug resistance? Well, maybe viral load data could be a good idea. Or maybe we could come up with something else. Maybe you guys have an idea. Okay, well, maybe for HIV we don't have that data, but I'm just thinking on my head, maybe for another disease we have that data, and we can see what governments already did to act on that, and in those countries that technique worked, or in that country that technique worked. I'm just thinking here, come up with ideas. This is what Johnson & Johnson is also looking for. We realize that you are not going to find in 2 days of workshop, well, we hope you do, but we realize it's not a valid assumption that you guys will come up with something that PhDs and professors have been working on for years. So we know that, but we are looking for those new ideas, that perspective that we haven't thought about. So that's really, that was the last point I still wanted to make.
So that's your challenge. We have 4 weeks. We will come back together here at the same place on the 27th of September. We will swap the classroom. It will be up to you on that day to explain what you've done with your team. Challenge us by your results for us to work even harder. Show us what you've done. Try to create that group. Reserve your day of the 27th of September, because that's where we will come back together here, and we will make sure that during that day we will have seven different ideas that where people have been worked on, so that you can learn from them, see how they did the visualization, or see how they fill in the gaps, because it's going to be a lot of filling the gaps of missing data. Thank you very much. I would like to thank again Serge for being here, and Jenny for all the work she's put in, and Elise for being as faithful to the community, and an example for all of us, all the boot campers at the back, and all of you who made up some time available to work on a very good purpose. You are going to learn, and you are going to make this world a much better place. Thank you very much.
Thank you very much. Merci.
So there are tables, you just, you can grab the smartest one.